Hi, my name is Stewart Lynch, and in this video we're going to be exploring Homescreen QuickActions. On the home screen of a device running iOS 13 or later, apps can display Homescreen QuickActions when the user presses briefly on the app icon. These actions can be either static or dynamic. If they're dynamic, you'll be able to give your users the ability to choose which ones that they'd like to have displayed as those quick actions. We'll be coding our sample app to respond to the actions tapped to filter a list of items based on the classification selected. This video is sponsored by Stream. Stream Chat is the easiest way to add messaging to your iOS app. The high-level components connect the Stream API with minimal coding, and you can get a free version of the Stream API with full feature access for personal projects and qualifying small startups. This makes it perfect for those side projects. You really need to check this out. Use the link in the description below to apply now for your full and free access to Stream's chat and activity feed APIs. No credit card is required. If you like this video, please leave a comment below and give it a thumbs up. Be sure you subscribe to my channel and make sure you ring the bell to get notified of new videos. If you want to support my work, you can buy me a coffee. Currently, our app is a single view that uses a view model injected into the environment that will present data in a list view and allow me to tap on a button to filter based on the selected classification from the segmented picker. The onChange function will react to changes of that property and call the view model's filter function to refresh the view. The items displayed are a static array of items that have simply a name, a classification, which is this enum, and an emoji. When the view model is initialized, it calls the load function, which assigns the static array, sorted by name, to the published and observed property. The filter function will filter the array based on the selected classification set by the picker and then change the navigation bar title. It's at this entry point here in the QuickActions app that the view model is instantiated and injected into the environment when the view appears. I just set this user defaults value here to prevent constraint warnings showing up on the console. Included assets are the app icon, an image that we'll be using shortly, and an image for the launch screen. I find that the info.plist version of adding an image to the launch screen in SwiftUI quite buggy, so I'm using a storyboard. And once you have a storyboard, you can specify that to use on the General tab of your app's target. Each home screen quick action includes a title, an icon on the left or right side depending on your app's position on the home screen, and an optional subtitle. And you can define quick actions statically at build time from the app's info.plist or dynamically configured at runtime. And we're going to be doing both. We're going to create a quick action that will launch and filter our list items depending on which action is selected. We'll create a static action that will always remove any sort order that may be in place and display all of the items. We'll follow that by creating quick actions for each of our other classifications and allow the user to choose which ones they want to have displayed as the quick actions. Since we'll always have that one that will be used to present all of the items when we select it, this will be our static action. Now you may think that this isn't necessary, because when you launch the app, it always shows all of the items. However, if you filter one of the classifications, and then return to the home screen, and then launch again, that filter is still in place. So we'll want to be able to have an action that will remove that filter. So from the info.plist, tap on the plus button on the end row and choose Home Screen Shortcut Items. Drop down the disclosure triangle on that new row, and this displays an item with no content. Drop that down and you'll see two different rows, shortcut item type, and title. These are the 2 required items for every shortcut action. The title should be obvious, so it's just a string that's displayed to the user for the quick action. So let's specify for our static action, show all items. The second item is a UI application shortcut item type, and it's a bit more nebulous. It's a required string that's delivered to your app when the user invokes the corresponding quick action. And your app can use that string to classify quick actions into types and then to disambiguate among action types it receives. Well, we're not really going to be using this at all. In this case, then, we're just going to pass in a string corresponding to our enum that'll trigger this action, which is the all. If we run the app now and return to the home screen, we can long press on the icon and we'll see the title, but no icon. So let's return to the plist then and add 2 more rows, subtitle and icon type. For the subtitle, I'm going to enter all of my stuff. For the icon type, we can refer to the documentation, and it's an enum with a number of different cases, and that enum is an int, but we're required to enter a string value in our plist. Well, it turns out that we can simply enter the word UI application shortcut item type followed by that enum's name capitalized. So for example, let's choose the home enum case. Let's run the app once more now and return to the home screen. A long tap, and now I can see that subtitle that we entered and our home icon. And when we tap on it, it opens the app, but it really doesn't do anything yet. We'll get around to that shortly. Now, before we look at how to process that action, let's add some dynamic actions. Dynamic quick actions depend on specific data or state of the app. And these are added to the app not when the app launches, however, but when the app goes into the background phase. And this means that when you first install an app from the App Store, you'll have to run the app once before any dynamic quick actions are added. Well, we can add these actions at any time, but we're going to want to allow our users to choose which of our actions to be displayed as quick actions. And so the best place to do this is to add them when we enter into the background mode. And for this, we're going to need to know when that state changes. And that's known as the scene phase. Well, fortunately in SwiftUI, this can be determined by an environment variable. And this is the environment variable scene phase. And we'll assign it to a variable called phase. And we can watch for changes on that phase in an onChange block. Now, the scene phase has 3 different cases. Active, and that's when the app is brought into the foreground and it's interactive. It could be interactive when the scene's in the foreground, but it should pause its work. And background when the scene isn't visible at all in the UI. That's when it's been set back to the background. Well, we're only interested in those first and the third phase, when the app is made active so that we can respond to any quick actions, and the background phase when we want to create and set our selected dynamic quick actions. To handle the creation of our dynamic quick actions, I'm going to create a new file. And I'm going to call it Quick Action. For the body of the file, I'll create an enum using that same name. And inside there, I'm going to create a number of static properties so that I can use the enum as a namespace to get code completion to get access to these static properties. First, I'll create a static optional property called Selected Action, and that's a UI application shortcut item. And this will be the dynamic action chosen when we tap on it. Notice how UIKit was immediately imported? That's great, but we no longer need Foundation. So when the action is selected, we'll need to pass on to our app some information that it can process in the active scene phase that was just created. Well, this will be a dictionary, and our dynamic action will use this as its user info property. So for each of our 4 different classifications, I'm going to have to create 4 computed properties for user info. So first, let me create one called pet user info. And a user info is a dictionary. And for the key, it will be a string. And the value is of type NS secure coding. And basically, this means that we can use a string as long as we cast it as an NS secure coding. So for our key, for each one, we'll use the string name. And for the type, we'll use the raw value of the info.classification type and cast it as NS secure coding as required. Let me just make a copy of this and paste it 3 more times. And then I can replace pet with the corresponding classification's raw value: electronic, sport, and family. Well, now that we have all of our 4 user info computed properties, we can create an array for all of our shortcut items. So it's another static property that I'll call all shortcut items. And it's an array, and it's an array of UI application shortcut item. So let me use the full initializer to create our first one. And for the type, I can just assign a string like we did for our static one. So again, I'll just use the same string as our raw value for our enum, in this case pet. The title is what's displayed, so I'll use capital pets. And for the subtitle, I'll type my pets. Now the icon is a UI application shortcut icon, and I have 3 different initializers to choose from. I could use a type like I did for the static property, or I could use a system image, which is an SF symbol, or I can use an asset template. Let's use the system image name, and I'll use the SF symbol pawprint.fill. And then for the user info, we'll just use that computed property pet user info. So I'm going to copy and paste this 3 more times, and then update the strings in the user info. For sport, I'm going to use a template image name of sports icon, and that's the icon asset that we have in our assets folder. For family, I'll choose the type initializer, just as I did for our static property, but this time I can use an enum, and I'll choose contact. For electronic, let's use another system image name, and this time I'll use laptopcomputer.and.iphone. Well, now that we have all of those actions, we can add them when our app goes into the background. So I'll create a simple function in our view model called add QuickActions. And then in the body, to assign those to our application, we can use the UIApplication.shared.shortcut items property and assign that QuickActions all shortcut items array to that property. And then finally, at our app's entry point, when the scene phase changes to background, I can call this function. Let me run the app now, and then I'll exit back to the home screen, and then long tap, and I can see my new actions. But do you see a problem? only 4 are being displayed. That static one for all, and the first 3 of our dynamic actions. Electronic is missing. And when we tap on one of these actions, no filtering is done. Well, it turns out that there are a maximum number of actions allowed, and that is 4. So we're going to have to give the user the ability to choose which ones they want. And then we're going to have to also be able to react to that choice and filter our list. So let's work on the latter first, responding to the action. To respond to the actions, we're going to have to invoke an app delegate and a scene delegate function. However, the new SwiftUI app lifecycle doesn't have any app delegate or scene delegate, but that's not a problem. We can create them. So let's do that by creating a new file, and I'm going to call it delegates.swift. I'll change the import to import UIKit. First, I'll create a new class that I'll call appDelegate, and it has to conform to both the NS object and to the UI application delegate protocols. This is going to give us access to a number of delegate functions, and the one that I want is the application configuration for connecting. And I can see that this is going to return a UI scene configuration, and we don't have that. So this is going to require that we create a scene delegate. So let me create a custom one I'm going to call QuickActions scene delegate that's going to conform to the UI responder and the UI window scene delegate protocols. This conformance then allows us to have access to the Windows scene's perform action 4 shortcut function. I'm going to choose the one with the completion handler. And for the code, we can assign the shortcut item to our static selected action property from our QuickAction enum. Well, now that we have that back in our app delegate then, one of the options that we'll get is the shortcut item. And it's optional. So we can use an if-let to unwrap it and then assign that to the QuickAction selected action. Having this then, we can create a scene configuration file, and we'll call it scene configuration. And it requires a name that is a string and a role. For the name, we can really use anything, so let's just use QuickAction scene. And then for the session role, it's a connecting scene session.role. Now then we can assign that new delegate class to this configurations delegate class and then return it. The final thing that we need to do here then is to make sure our SwiftUI app knows about our app delegate. So back at the entry point, we can specify this using the UI application delegate adapter property wrapper, specifying the app delegate class and assigning it to a variable called appDelegate. Now we'll get notifications whenever our app becomes active. So we'll be able to respond and pass along the name associated with that user info of that shortcut item coming in. We can then let our view model deal with that. So let's create a function in the view model to handle the action that's coming in, and we're going to be passing in a string, which will be the user info key names value. So function select filter for name, which is a string. And that name corresponds to the raw value for our enum, because that's how we specified it. So we'll want to assign that to the selected classification. But the selected classification is an enum, so we'll need to convert it. So we'll use an if-let classification and see if it's equal to the item classification's raw value specifying the name. If so, we'll assign that classification to the selected classification and then call the filter function. Back at our entry point then, we can call that function once we have extracted the name. Well, we can extract that name then from our QuickActions selected action user info name key. So it's optional, so we'll use if let name equals quickaction.selectedAction.userInfo name and cast it as an optional string. If it exists, we'll pass that name to the viewModel's selectFilter function. Otherwise, we didn't get one of our dynamic actions tapped on. We'll set our viewModel selected classification to all, and then essentially remove the filter by applying the load items function. Let's run the app now, and I'll exit to the home screen. Let me long press and choose one of our quick actions. And when it opens, the list is filtered. Perfect. Let's exit to the home screen again, but tap on the app to launch it. And it comes back showing that same filter. Let me exit back to the home screen once more. This time I'll long press and choose the Show All Items action. This time it loads and displays all the items. Perfect. So the last thing we need to do now then is to be able to choose which actions we want to have as our quick actions, because right now we're not showing the electronics action. And that's actually more important to me anyway. Well, the first thing I'm going to do then is create some default actions that I can use on first launch, and then we'll be able to update those later. So in the view model, I'm going to create a new published property called selected items, and it's going to be an array of our enums, which are the item.classification enums. And I'll choose pet, sport, and electronic. Next, let's create a new SwiftUI file. And this is going to be a view that we'll use to be presented so that we'll be able to make our selection. So let's call it configure view. Inside there, I'm going to add an environment object so that we'll have access to our view model, and then add an instance of that to the preview to stop it from complaining. Now we're going to be presenting this on top of our content view when we tap a button, and we'll be using a Z-stack for that. So we'll need a binding to a Boolean property that will get passed in. So let me call that binding show configuration. And again, to stop the preview from complaining, I'll just add a constant of true. So first, let's create an array of all of the classification items. Well, it turns out that our classification enum conforms to the all cases protocol that allows us then to generate an array. And we can then filter that array whenever that item in the array is not equal to the all case. Now we'll want to create a list of these items, so I'm going to replace the text view with a list that uses self as the ID. And it'll iterate through each one of these classifications, and I'm going to present an H stack where the first item in the H stack is a text view that uses that iteration classification's raw value, but having it capitalized. Next, within the H stack, I'll add a spacer and then a button. Now for the label, I want to use an image, but that image is going to change depending on whether or not that classification is within our selected collection. Oops, I have a typo in view model, so let me correct that first. So back here then, I'll use a ternary operator to see if that selected items contains the classification. If so, I'll display a checkmark.square.fill. otherwise a square. Now I'll come back to the action in just a minute, but let's improve our design first by adding a list style of plain. I'm going to embed this entire list inside a navigation view, and that's going to allow me to add a navigation title. And I'm going to specify that title as the string configuration. And I'll also set the display mode to be inline. Now I want a button on the toolbar of this navigation view so that I can dismiss this presented view. So I'll create a toolbar, and within the toolbar, a toolbar item where the placement is navigation bar trailing. Now that item I want to be a button. And for the label, I'll use an image using the system name x.circle.fill. And then for the action, in order to dismiss the view, we'll simply toggle the show configuration Boolean property, but we'll do it with the animation so that it fades out nicely. And then finally, I'll add some shadow and a frame. So for the shadow, we'll use black with an opacity of 0.2 and a radius of 10 all around. And then for the frame, to constrain the dimensions, I'll set a width of 200 and a height of 225. Now back to that action. When we tap on one of the rows, if that item is in the array, we'll want to remove it. If it's not in the array, we'll want to add it. So we're going to have to find out, if we're going to remove it, what index that is. So we're going to use an if-let to grab the index, which is the view model's selected item first index, where the classification is equal to one of the items in that selected items array. If that's the case, we'll need to remove it at that index. If it failed to find the index, then we need to add it using the append function. In Content View, then, we'll need to have a property that's going to toggle the presentation of this view. So let's use the same name and create an state property called Show Configuration, setting it initially as false. Now we'll need to embed this entire navigation view inside a Z-stack. And then as the second item in the Z-stack, we can conditionally present that new view. So if show configuration, we'll use configuration view passing in as a binding that show configuration. Now all we'll need is a button to toggle that state with some animation. So let's add another toolbar, and inside that toolbar, a toolbar item with a placement that is the navigation bar trailing again, and we'll create a button. For the label, we'll use another system image, and we'll just use the gear system image. And then the action again we'll use with animation to nicely fade in the presentation of that view by toggling that state property. Finally then, since we've now updated the selected array, we'll need to update our actions when we go into the background. So we'll first need a property in our view model, and it'll be a computer property that will gather all of those selected actions in an array. So it's an array of UI application shortcut item. So in the body, let's just start with an empty array, which is selected actions, an array again of UI application shortcut item. And then we'll loop through each one of our selected items. and then use if-let, creating an action. If the QuickActions, all shortcut items, all of the items in our QuickActions, finding the first one where the type is equal to the item's raw value. And if that's the case, we'll append that action to our selected actions array. And then we can return that for our computed property. Well, now that we've got that complete array, we can then, in the QuickActions function, remove the assignment of all of the actions and only assign the selected actions. Now we can test. Let's run the app now. And let me tap on the Configure button. I'm just going to select Family and Sports. And let me return to the home screen. And if I long press on the icon, this time we only see those two actions. Let's tap on Family, and it opens and it filters just by that category. Let's try Electronics. Great. There's only one more thing we need to test, and that's the All action. And it works too. That's it. I hope you found this video useful and that you'll be able to incorporate this into your own applications. If you enjoyed the video and you want to support my work and see more like this, you can buy me a coffee. Thanks for watching.